Thank you so much, Professor. First of all, I would like to introduce myself. My name is Rehanullah. You can also call me Livan Khan. I belong to Pakistan. My date of birth is 3rd March of 1993. My hobbies are hiking, exploring new places, and minor repair at home. My favorite animal is mouse. My hometown is Dirloor, famous food including biryani and chapli kebab, and my tourism attraction is toward Talash Valley. My educational background is that currently I am a PhD student at the Department of Biomedical Engineering (CYCU). My master in philosophy and zoology was from Government College University Lahore, and my bachelor in sciences in zoology was from University of Malakand. My research background including nanobiotechnology, neurosciences, physiology, and environmental sciences. So today I am going to represent about spectrophotometry. There are two general terms, spectroscopy and spectrophotometry. So spectroscopy are all those methods used to produce and analyze light spectra using spectroscopes, while spectrophotometry detect the intensity or the amount of light passed or absorbed through the molecule using spectrophotometers. So after that, there are two common terms, absorption versus emission. So absorption is the process in which the electron in a compound absorb the photon or the light energy. The light energy is in the form of photon. So this energy will be equal to h mu, where h is a Planck constant. So uh, if the incident energy corresponds to the energy of the atom, so the atom will excite from ground state to high energy level, or from E1 to E2 state, and the energy absorbed will be equal to the difference of energy in between these two states. So after some time, just in millisecond, the absorbed energy must be re-emitted. And so after calculating or detecting the re-emitted energy or photon or light wavelength, so we can detect this re-emitted energy, and this is the basic principle of spectrophotometer. Spectrophotometry, generally a method to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam of light passes through a sample solution. Basic principle is that each compound absorbs or transmits light over a certain range of wavelength. So it is a most useful method for quantitative analysis in various fields, including biomedical engineering. Every chemical compound absorb, transmit, or reflect light over a certain range of wavelength. So, thus, amount of light detected after passing through a compound is analyzed for quantitative estimation. Therefore, spectrophotometer is a device designed for evaluation of spectrophotometric measurement. There are some component of spectrophotometer. Light source for visible spectrophotoscopy or spectrophotometer, the tungsten lamp are used, while for the ultraviolet light, deuterium or hydrogen lamp are used. Colorimeter, colorimeter are the component of spectrophotometer to produce a paler beam of rays, while monochromator are used to select a certain range of wavelength per measurement. So it splits light into component wavelength, and wavelength select certain type of wavelength and block other unwanted wavelength of light. Per sample in the form of liquid, cuvettes are used. So there are many different type of cuvettes. For example, for visible light, glass cuvettes are used, and for ultraviolet, quartz cuvettes are used, and for infrared light, silver chloride or potassium bromide cuvettes are used. Detectors are those components which detect the emitted light after passing through the compound, and so it converts light signal into an electrical signal. So these are the components of a generalized spectrophotometer. This is the light source, this is the collimator, and this is the prism or diffraction grating, and this is the wavelength blocker or that blocks other type of wavelength and select certain type of wavelength. So the basic principle of spectrophotometry are the incidence of light source, then use of collimator such as a lens, and then monochromator and the form of prism or grating substance, and then wavelength selector, and then we have to pass this selected beam of light over our sample, and then after passing the sample the detector used to amplify the signal and fed to system for analysis. So spectrophotometer, a device that produces typically disperse and measure the light, while photometer indicate the photoelectric dictator that measure the light. Um, Spectrophotoscopy goes a law called Beer-Lamper law. This states that the absorbance of light by a material in a solution is directly proportional to its concentration and that solution. So it is a direct relationship, and the concentration is directly proportional to the absorbance. So if a compound has higher concentration in solution, the absorbance will be maximum. So it is mathematically represented that the absorbance is directly proportional to epsilon LC, where A is the absorbance, epsilon is molecular absorptivity, L is the path length of the light absorbing sample, just like the width of the cuvette, and C is the concentration of absorbing species. It is important to determine the unknown concentration when comparing to the known concentration. Therefore, it is a type of correlation. So this type of correlation is called calibration curve. So calibration curve is stated that it is a standard curve. So it is made to determine the concentration of substance in unknown sample by comparing the uh, unknown to set of standard sample of known concentration. So it is a type of correlation. So in this diagram we can see that as the concentration of the compound in a solution is increases, the absorbance also increases. So it is a type of correlation relationship. Type of spectrophotometer. There are two type of spectrophotometer. One is single beam instrument, and the another one is double beam instrument or spectrophotometer. If spectrophotometer contain only one chamber for the test material or the blank material, it is called single beam instrument. So only one type of pathway is traveled by light in this type of spectrophotometer. While in double beam instrument there are two separate chamber for sample and as well as blank, and both are simultaneously measured. So different mirror are used, gone by a motor to disperse certain amount of wavelength of light on the reference cuvette as well as on sample. So it is the blank and it is the sample. So both are automatically measured and then detected by photo detector. We know that each and every compound have atoms and molecules and atom, and these atom and molecules are continuously in motion. This motion may be transition, vibration, and rotation. If any one of these motion can correspond to the incident of light, the same amount will be absorbed, and after that this amount will be re-emitted. So the re-emitted light will be detected after providing a fine detail. So it is a very basic principle for the spectrophotometer. The absorption spectrum: when a sample is exposed to light energy that match the energy difference between a possible electronic transitions within the molecule, a fraction of light energy would be absorbed by the molecule and the electron would be promoted to the higher energy state orbital. So orbital is the uh, region around the nucleus where the probability of electron is maximum. So if this energy, the incident photon energy, is corresponding to the energy of the atom, that may be vibrational, rotational, or anyone, so it will absorb that amount of energy, and the electron in that element, an electron in that compound will be promoted from lower energy state to high energy state. So spectrophotometer record the degree of the absorption by a sample at different wavelength, and the resulting plot absorbance versus wavelength is known as spectrum. There are two terms: lambda maximum, it is the wavelength at which there is a maximum absorption can occur, and the epsilon maximum, it is the intensity of maximum absorption. So we can also use the absorption of a material by the absorption applied by a material is also used for the analysis of purity of that material. We have certain type of spectrophotometry: the ultraviolet spectrophotometry, visible spectrophotometry, and atomic absorption spectrophotometry. As we know, there are 9 type of photon or energy spectrum, from gamma to long radio wave electromagnetic radiation. So we are concerned about the UV region of the spectrophotometric region, or electromagnetic radiation, and the visible region and IR region. So the general background of ultraviolet spectrophotometer is that it uses light over the UV range, and the UV range is about 180 nanometer up to 400 nanometer. Filters are used to generate a beam of light with bandwidth of around 10 nanometer. A prism of suitable material and geometry will provide a continuous spectrum in which the component wavelengths are separated in space. For ultraviolet spectrophotometry, bandwidth of 1 nanometer is achieved to greatly enhance the performance by using prism monochromator. In addition to prism, diffraction grating are also applied for producing monochromatic light. A diffraction grating comprises of series of ferrule grooves on a reflecting surface. Grooves can be considered as separate mirror from which the reflected light interacts with light and reflected from the neighboring grooves to produce interference. For UV spectrophotometry, quartz cuvettes are used. Another one is visible spectrophotometry. It uses visible range. The visible range is from 400 to 700 nanometer of electromagnetic radiation, operate best in the range of 0.2 to 0.8 optical density. It is used for printing, textile, ink industries. Several reading across every 5 to 20 nanometer along the visible spectrum are taken to produce spectrum reflectance curve or data stream for alternative presentation. So these curve can be used for the reproducibility of various batches of ink. For this visible spectrophotometry, plastic or glass cuvettes are used. Application of ultraviolet visible spectrophotometry or application of UV visible spectrophotometry and biomedical engineering. Clinical diagnosis: to study enzyme kinetics, enzyme activity can be studied by analyzing speed of reaction. Reagents are attached to the substrates which can monitor for enzyme activity. Widely used in the field of clinical diagnosis, such as an indicator of tissue damage. Entry of enzymes into bloodstream upon tissue damage indicate that the extent of tissue damage depending upon the enzyme activity. Assay through spectrophotometric analysis, such as in pancreas, liver, or other tissue damage. Dissolution in vitro release assay of drug formulation design depend largely on drug dissolution profile, and also in vitro release assay for pharmaceutical agents or molecule and assay spectrophotometrically. So quantification of DNA, RNA, and protein based on absorption profile or property of biomolecule, they are quantified with greater precision through UV visible spectrophotometry. Dye and paint industry. Spectrophotometry is used in the quality control and the development of dyeing reagent and paints. It is also used for the heavy metal and other toxicity analysis and for organic matter from environmental agriculture sample. So this field sample are also used to monitor or assess for the health and other nutritional uh, concerns. Infrared or IR spectrophotometry. It is uses light over infrared range. This is the 700 to 15,000 nanometer of electromagnetic radiation spectra. But it is not so practical because of the limitation that everything emit IR light as a thermal radiation, especially wavelength beyond 5 micrometer. And moreover, glass or plastic material absorb IR, thus making them incompatible for cuvette material. So what to do? A material for IR spectrophotometry is good with salt like potassium bromide, or when liquid material is to analyze, then it is placed in silver chloride cuvette. The last one, atomic absorption spectrophotometry or AS. It detects down to 40 per billion or ppb of a gram. These techniques use of wavelength supplied specially absorbed by an element corresponding to the energy needed to promote electron from one energy level to another energy level. And hollow cathode lamp contains tungsten anode and a hollow cylindrical cathode made of element to be determined. These are sealed in a glass tube filled with an inert gas, neon or argon, and standard curve or calibration curve is generated using various sample of known quantities, and then unknown sample is run and analyzed. Atomic absorption spectroscopy application in biomedical engineering. It detect the detection of small amount of metal, for example lead, mercury, arsenic, calcium, and magnesium, and also help in environmental study like drinking water, ocean water assessment, soil, and food industry and pharmaceutical industry, and also used to determine metal in tissue or other material. So thank you so much for listening.